Welcome to saitechinfo, my dear students. In this tutorial, I'll be explaining about the one-to-one function, on-to function, and based on that, how to arrive at the invertible function. Now, let us consider this problem. A is equal to or excluding the number 3. So it's a real number that excludes 3. B is given as the set of real numbers excluding 1. The function is defined as the relation between A and B, where f of x is given as x minus 2 divided by x minus 3. Show that f is 1 to 1 and on to. So we have to show this given function f of x is equal to x minus 2 divided by x minus 3 is 1 to 1 function and also on to 1 function. If both are possible, then it can be called bijective function. And it is invertible, so we need to find out the inverse function of the given one. We will try to understand the meaning of this problem first of all. See, A is the input, B is the output. We know what is relation. Relation is the set of ordered pairs. So first of all, we should try to establish the set of ordered pairs. Okay, so we should have this. Let me consider A1, B1, A2, B2, A3, B3, etc. So this is the set of ordered pairs where A is the input, B is the output. We can explain like this because we already know R is the relation and it is the set of ordered pair. Why it's called ordered pair? They are available as A1, B1, A2, B2, A3, B3. What do you understand from this? This is nothing but the input and output. See, let me consider y is equal to f of x. That is a given function. So this f of x here, x is the input and y is the output. Based on the input, the output will vary, and that is why this input, that is x, is called independent variable. Whereas the output depends on the input, and that is why y is called dependent variable. Now the given function is y is equal to x minus 2 divided by x minus 3. And as we already discussed, A is the input, B is the output. Now they have given A as the set of real numbers excluding the number 3. And B is the set of real numbers excluding the number 1. So what do you mean by this? In fact, you should not get confused with this R and the relation here. So this indicates the relation, the set of ordered pairs, whereas this one is a real number. Do you understand? So when the A is clearly defined here as the set of all possible real numbers, excluding 3. So they are given in the set builder form. So we need to convert this into the roster form so that you will try to understand something from this. So this is the, see, they are given A as R excluding 3. So let us have the input. For example, here I have the input. So A is the input, which is nothing but the x variable, independent variable. Based on that, you will be getting B. So A and B are clearly defined here. How they are clearly defined? A should be the set of real number excluding 3. B should be the real numbers excluding 1. Why they have given for this particular function? Because we'll try to understand. For example, let me say, see, that is excluding means impossible, that is not possible. So you should not consider 3 as A. As well, 1 as B. Let me explain why it is given like this. For example, you have got the input 1, 2, 3, 4, we can include everything. But what is the condition given here? That is, A should be real number apart from 3, excluding 3. So I have striked out 3. Similarly, B is given as a set of real number apart from 1. That is, 1 should not be included. So I have striked out 1. Anyway, that is set of real numbers, so you can put all real numbers. But I have got some specific values because I already suggested that y is the dependent variable. So we will try to work out and find out the value of y for every x. Let me take up first of all, that is x is equal to 3. But what is given here? X is not equal to 3. You should avoid 3. Anyway, that is purposely I have taken x as 3 in order to explain this. Y is equal to, now you have got the function y is equal to x minus 2. So in that case, substitute this 3. So 3 minus 2, 1. 3 minus 3 divided by 3 minus 3 is 0. So 1 by 0 is equal to, that is infinity. It cannot be determined, and that is why don't consider this 3 as the input, and that is why they have very clearly indicated in the sum as or excluded 3. I hope now you should be able to understand this point. Second point, y is not equal to 1. It means that is the result should not be 1. That is, I have striked out this 1. So let me purposely tell, that is, let me replace y is equal to 1. So I have put 1. So x minus 2 divided by x minus 3 is equal to 1. Then in that case, what could be the value of x? So x minus 2 and here x minus 3. Now x minus x is 0. So 0 cannot be equal to minus 1 according to this. And that is why they have excluded 1 from y. I hope now you should be able to understand the given conditions. Okay, so these are the conditions. Anyway, let me look into the other aspects. For example, since A is the set of real numbers, I can take 2 or 1. So when x is equal to 1, what happens here? When x is equal to 1, y is equal to, you can substitute, that is 2, 1 minus 2, 1 minus 2, 1 minus 3 is equal to minus 1 divided by minus 2, that is equal to 1 by 2. And so I have got this 2 when x is equal to 1. So I can relate like this. Okay? Right. Next. Let us consider, that is, x is equal to 4. When x is equal to 4, then you can replace this value. So y is equal to 4 minus 2 divided by 4 minus 3, that is equal to 2 minus divided by 1, that is 2. So I have related 2 because I got the value 2 when I substitute the value x with 4. Now let me consider x is equal to 2 and work out. So x is equal to 2 means y is equal to 2 minus 2 divided by 2 minus 3. So 0 by minus 1, that is equal to 0. So that is why I have included 0, because it is permitted, because it's a real number. So 0 is one of the real numbers, is it not? And it can be a fraction also. Okay. So I have now arrived at the complete roster of A and B, or the diagram model of the relation. I established this one. Are you able to follow? Right. Now let us look into the problem, how to solve this problem. Okay, so I have just explained the inputs and outputs, and so that you should be able to understand the problem very clearly. Now let me look into the problem. Okay, right. Now we have let me continue this problem. What is given here? That is, it is asked, that is, to show f is 1 to 1. Let me write down clearly the given. What is given here in this question? A is equal to r minus 3. So this part I have explained. B is equal to r excluding set 1. Okay, so this point is very clear. Now the function is given such that A is related to B, where f of x is clearly defined as x minus 2 divided by x minus 3. So this is the given function. We have to focus on this. Now these are given. What to do to show that? Show that f is 1 on 1 function or 1 to 1 function. Then f is on 2 function. So these are the two we had to prove. This is the first one. And based on that, we have to find out f inverse is equal to what? When both are feasible, we know it is called a bijective function. Okay, so when they are bijective, then it is invertible, and we have to find out the f inverse. Now let me consider the 1 on 1, that is 1 to 1. Here we know what is the concept. When f of x1 is equal to f of x2 and it results, that is x1 is equal to x2, means it clearly indicates that it is an 1 to 1 function. Okay, right. Now let me proceed. F of x1, let me put f of x is given here, that is x minus 2 divided by x minus 3. Let me write f of x1 is equal to x1 minus 2 divided by x1 minus 3. Then f of x2, so replace the value of x with x2. So x2 minus 2 divided by x2 minus 3. Now let me consider this is equation 1, this is equation 2. Let us apply this in equation 1. So what is f of x1? x1 minus 2 divided by x1 minus 3. So x1 minus 2 divided by x1 minus 3 is equal to f of x2. So x2 minus 2 divided by x2 minus 3. Okay, right. Now let us show that x1 is equal to x2. We will check. If it comes like x1 is equal to x2, then we can confirm that this is 1 to 1 function. Okay, right. Now we can cross multiply. So x1 minus 2, always put the bracket safely, into x2 minus 3 is equal to x1 minus 3 into x2 minus 2. Now let us multiply, that is by x1, x2. So x1, x2 minus, and then 2x1, 2, and then multiply by 3, that is minus 3 x1 and minus of minus plus 6 is equal to, similarly you can multiply by x2. So x1, x2, and then minus 3 x2, then multiply by minus 2 x1 minus of minus plus 6. So x6 can be cancelled. x1, x2 can be cancelled. So the remaining part is 3x2, and you can bring this 3x2 here. So 3x2 minus 2x2 is equal to, you can bring this 3x to the other side. So plus 3x1 minus 2x1. So it means x2 is equal to x1. Therefore, it is a 1 to 1 function. So the given function is 1 to 1 function. Okay, so this is the first proof. Are you able to understand? Right. Now let us proceed with the second one. Okay, that is, we had to show this is onto function. Okay, right. Now let me consider the second part, that is onto function. Right. See, the onto function is, that is, let me consider this f of x is equal to, that is a given one, x minus 2 divided by x minus 3. So we should get this f of x as, that is, y. When you get f of x as y, then you can declare that this is an onto function. How to proceed? Let me consider, that is, y is equal to, okay, y is equal to x minus 2 divided by x minus 3. Got it? So y is equal to x minus 2 divided by x minus 3. Okay, follow it carefully. Now this we can multiply here. So yx, that is y into x minus 3 is equal to x minus 2. So yx minus 3y is equal to x minus 2. You can bring this x here. So yx minus x and bring this 3y here. So plus 3y minus 2. So x can be taken outside the bracket. So y minus 1 is equal to 3y minus 2. Now x is equal to 3y minus 2 divided by y minus 1. Okay. So I have interpreted the 3y minus 2 divided by y minus 1 as x here. Okay. Right. Now we know already f of x is equal to, that is a given function, x minus 2 divided by x minus 3. This is the given function. Okay. So what we are going to do is, we are going to substitute this in this x. Okay. Therefore f of x is equal to, in place of, that is this x, we had to substitute this 3y. So 3y minus 2 divided by y minus 1 and then minus 2. So I have replaced this x by this value of x whole divided by, and this must be substituted by this value. So 3y minus 2 divided by y minus 1 minus 3. Now let us take LCM. So that is y minus 1 is the LCM. Okay. So this is 3y minus 2, multiply, and you will get minus 2 and then minus or minus 1 plus 1. Okay. Whole divided by, right, whole divided by, that is 2 into y, minus 2y, minus 2 into plus 2. Okay, right. And here 3y, that is y minus 1 is the LCM for the denominator. Now 3y minus 2 and multiply this 3y minus 3y and then minus 1 into 3 plus 3. Okay, so this is equal to, now I can reciprocate, before that we can solve, 3y minus 2y, y, 2 cancelled, divided by y minus 1. Now we have to reciprocate, before that we will solve. 3y minus 3y cancel, so 3 minus 2, 1. So I can put y minus 1 divided by 1. So I can cancel this. Now I am able to get, that is y. So here I am able to get the value of y, that is f of x has become y now. Okay, so hence the proof. It means f of x is a onto function. Therefore you can declare that f of x is onto function. Okay, is it clear? Right. So since it is one to one and on to, it is bijective. Okay, so that too can be proved here. So therefore f of x is bijective and invertible. Okay, if it is bijective, then it becomes invertible and invertible. Now let us try to understand the inversion of a function. The given function is f of x is equal to, that is x minus 2 divided by x minus 3. Let me consider y as x minus 2 divided by x minus 3. Okay, now let us interchange the x and y. Interchange. So what we are going to do is, we have to find out the inverse function. Inverse function. This is the third step. Okay. So interchange x and y. It means x is equal to y minus 2 divided by y minus 3. Got it? Now let us multiply xy minus 3x is equal to y minus 2. Okay, so here, that is xy minus y. You can bring this y here. So xy minus y is equal to, put this 3x on the other side as 3x plus 3x. 3x minus 2. So take the GCD, y is the GCD, you can take outside the bracket. So y of x minus 1 is equal to 3x minus 2, and therefore y is equal to 3x minus 2 divided by x minus 1. Okay, so this y is the, that is inverse of x. So this is declared as inverse of the function, given function. Are you able to follow? Okay, so this is the third aspect of this question. Okay, so what are the key stages here? Let me explain one by one. Given question, a is equal to or excluding 3, b is equal to set of real numbers excluding 1. So what we have to find out, we need to show that a, the function is 1 to 1 and on to, and hence find f inverse. These are the three important questions. The given function is this one, that is f of x is equal to x minus 2 divided by x minus. So I have clearly explained the given statements here, and we have to show these three important one. And first one is 1 to 1, and the concept is f of x1 is equal to f of x2, that is x1 is equal to x2. So both these conditions are fulfilled, means then it can be 1 to 1 function, and we have worked out, we have taken f of x as x minus 2 divided by x minus 3, and we have put f of x1, f of x2, and just relate this one and try to find out whether x1 is equal to x2. So we have got this one, so it is one-to-one function. Then on to function, so here the given function, so it should yield the y. So for which how we have to start, that is y is equal to x minus 2 divided by x minus 3. So interchange and find out the x value. So f of x is equal to what? I mean, once you have found out this x value, you had to substitute in the given function. So I have substituted this x by this new value. Similarly, this x also by new value, and finally I am able to get back y. So when you are able to get back y, then it is declared as, that is on to function. The given function is on to function. Third one is, and before that, when both are possible, then it's called bijective and it's invertible. So we have to find out the invertible function. How to proceed with the to determine the inverse of function. Here take the given f of x, that is function, and replace this f of x by y. Now interchange, this is a very important step, interchange x and y. So you call it x is equal to y minus 2, y minus 3, and work out interchange, find out the value of y. So when you get 3x minus 2 divided by x minus 1, that can be declared as f. So what is the meaning of this?